So this was the last thing we did. We did about the relative density, and I gave you the formula of relative density. That the relative density is the density of a substance divided by the density of water. So if you take the density of substance in SI units, so the density of water will also be taken in the SI unit. And since the relative density is a simple ratio, so therefore it does not have any units. Okay. So this much we had done. Any doubts up to here? Up to the relative density? No. Okay. So see, there are some important conclusions that we get from the value of the relative density. If you calculate the relative density of any material and the relative density of that material, if the relative density of the material is greater than 1, okay, if the relative density of the material is less than 1, or if the relative density of a material is equal to 1. So what do we observe if the relative density of a material is greater than 1? What do we conclude out of it? Abhinav,
Yes, sir.
what can we conclude if the relative density of a substance is greater than 1?
Sir,
Prince, what will we,
it
Chavan
will
Kaushik, what we will
float.
conclude if the relative density is greater than 1?
It will sink, sir.
Okay. So if the relative density of a material is greater than 1, then we mean that the density of the substance is greater than water and hence the substance will sink. So if the relative density of substance is greater than 1, it will sink in water. Okay. If the relative density is less than 1, so it will float in water. And if the relative density is equal to 1, so what will happen? Abhinav, what will happen if the relative density is equal to 1?
Um, I think I don't know, sir.
Okay. So see, if the relative density is equal to 1, so in that case, the density of the substance will be equal to the density of water. And hence, in this case, the substance will float. Here, the substance will float just below the surface of water.
Will float below the surface of water. Can you show
Yeah,
me
it
how?
will float just below the surface of water.
Like it will go down, then come up, or just stay down.
It's like this. Chavan, I think there is some issue from your side. I'm getting echo. Whatever I'm speaking, I'm getting echo if your mic is on. So I'm getting an echo from there. Okay. See, these are the three situations.
Sir, can you just show me the equals to one part one first?
Yeah.
Can you
Just
show
I'm
me?
showing you all the three things which are going to happen. So suppose if you have in a container, you have water, all of them, let's say all of them have water. Now, if you have a substance which has a relative density greater than if it has the relative density greater than the density of water, so the substance will sink. It will go down. If the relative density of the substance is greater, so it will float above the surface of water like this. And if the relative density is equal, so it will float like this just below the surface of water. It will float something like this. Okay. So here, in this case, we observe that the value of relative density is greater than 1. Here we observe that the value of relative density is less than 1. And here we observe that the relative density is just equal to 1. Okay. So got these all the three concepts?
Yes.
Okay. So with the relative density, we are complete. We will just solve one or two questions and then we will move to the next topic, that is structure of atom. Right.
Sir, will we get to electronic configuration in this class only?
Yeah, in the structure of atom, you have electronic configuration.
Yeah, but will we get to it this class? In 40
No,
minutes?
not in this class.
No.
Okay, see. Okay, see. Okay, see. See here, question number 21. Question number 21. Why does a block of plastic released underwater come up to the surface? Question number 21st. Smith, why does a block of plastic released underwater come up to the surface?
Sir, because density is less than water.
Because its density is less than water and hence it experiences an upthrust. Okay. So it comes above the surface of water. Then the volume of 50 gram of a substance is 20 centimeter cube. The density of water is 1 gram per centimeter cube. So will the substance float or sink? Aman? Aman, will the substance float or sink?
Sir, which question?
Question number 21. Everyone will solve question number 21. Siddharth, solve question number 21.
Sir, I think
Yeah, what will happen?
Sir, the object will sink.
The object will sink. Okay. So what is the relative density of the substance? Prince, what is the relative density of the substance?
sir, 20 upon 20.
Is the relative density 20?
Sir, it's 50 by 20, right?
Yeah, relative density is 50 by 20. That is 2.5 gram per centimeter cube. And if you find the relative density, so the relative density is also 2.5 and hence the substance will float. So substance will sink. Since it has a relative density greater than the density greater than 1, so the substance will sink. Okay. Now the question number 22. The volume of a 500 gram sealed packet is 350 centimeter cube. So will the packet float or sink in water if the density of water is 1 gram per centimeter cube? So just try to answer this question number 22. I'm expecting answer from everyone. I will check everyone's notebook for question number 22. And if you are not getting, just ask, I'll be explaining this. Complete question number 22. The volume of a 500 gram.
Sir, can you give me a minute? I'll do it in book.
Yeah. Pranaya has given the answer, but Pranaya, that's wrong.
So, like, what am I supposed to do? Am I supposed
For question number 22. Can you see question number 22?
Yes, sir.
Okay, that has to be done. The volume of a 500 gram sealed packet is 350 centimeter cube. And you have to tell will the packet float or sink in water.
So, I gave the answer, right?
Yeah, so that's incorrect. No? See, you have to calculate the density of the substance, and density is given by the formula mass by volume. Mass by volume. So density of the substance will be 500 divided by 350.
which is more than 1, right?
No, this is just density. This is just density. If you calculate this, this will be 10 by 7 gram per centimeter cube. And now you find the relative density. So the relative density of the substance would be 10 by 7 divided by 1. And this is again 10 by 7, which is greater than 1. Since this is greater than 1, therefore the substance will sink.
So that is what I said.
So you said, but your answer is incorrect. You did not calculate the correct value of the relative density.
Oh, sir, I didn't simplify it. I wrote 500 by 350 gram per cc.
Anyone
It
else who has calculated? Also do
Yes, sir, I did the same thing actually. I did
okay.
500
Also do the second
by
part. What will be the second part? What will be the mass of water displaced by this packet?
Sir, I sent it your answer.
Send, who has sent the answer? I got only the answer for Siddhisri.
Yes, sir,
Siddhisri,
I
I- okay. So you just said it will sink. You did not find out its relative density. Find the relative density, and after that you also have to find what will be the mass of water displaced by this packet. You also have to find out the let me see now who can Siddharth, have you calculated the second part? What will be the mass of the water displaced by this packet?
Sir, I found the answer.
You got the answer?
Yes, sir.
Okay, what is the answer?
Which question?
Sir,
Question number 22, second part.
Second part.
Yeah.
350 gram.
How did you get the answer? Can you show your solution?
It's M will equal P into V. Density of water into
So
uh,
how did we get that? Show your solution and tell me how do we get that? How do we arrive at
calculating the
the
mass of water displaced, so mass is equal to P into V, which is 1 into 350.
okay? So we find here weight of liquid displaced, and weight of liquid displaced is equal to the upthrust. Okay, weight of liquid displaced is equal to the upthrust, or you can also say that weight of liquid displaced will be equal to the volume of water displaced. And since the object is sinking, so if it is sinking, that means volume of water equal to the volume of the substance will be displaced out of it, right? The volume of the substance is 350 centimeter cube. So therefore, a volume of water equal to 350 centimeter cube will be displaced. If the block would not be sinking, had the block not sinking, it was floating, so then the situation would have been something else. Okay. So here weight of liquid displaced will be equal to V multiply rho multiply G. This would be the weight of the liquid displaced, where V is the volume of the substance, rho is the density of water, and G is its acceleration due to gravity. Now, if I just want the mass, so mass will be equal to weight divided by G, which is will be equal to V into rho. Volume is 350 multiplied by rho, that is density of water, which is 1 gram per centimeter cube. And hence the answer will be 350 gram.
So that's the same
Water
answer I got.
equal to, yeah, water equal to 350 gram will be displaced out of it. Okay. Fine. Now we start with the new chapter. I'm starting with new chapter now. Structure of atom.
Sir, can you just start with Thomson's model of atom?
What topic?
Sir, can you
Chavan, you have some
start with
issue with your.
Is it echoing now?
Yeah,
It is.
still it's echoing. Leave the class and rejoin. Chavan, leave and rejoin. Okay, so anyone has any doubt from this chapter? So our next topic is structure of atom. Today we are starting with the structure of atom, right? So I think all of you must have done a little bit or something about the structure of atom. When we started thinking of atom, why did we start thinking of the atom? When we saw the things around us. So it was Maharishi Kanas who first started thinking of the atom. So structure of the atom, why we went to the structure of the atom? First of all, we observed that all the objects around us, they are the matter particles. Okay. And they have some properties. Some of the substances, they have similar properties. Some of the substances, they have different properties. So of course, the substances which are made up of the similar properties or have the similar properties, they have similar things in them. And so on, we went on to define the atoms. Okay. So atom was the purest substance. Okay. So what is atom? It is the purest substance which is formed. Atom is the purest form of matter. Okay. So that we call as the atom. Now, the studies went on to find out the structure of the atom. How, if the atom is there, so how it is, how it looks like. Eventually, we cannot see atom. And if you say we cannot see atom, even then you are wrong. But you cannot see an individual atom, right? All the substances you see around us, they are made up of atoms. So you are looking at the atoms, but if you want to spot an individual atom and identify it, yes, this is this atom. So that is not possible. With our eyes, we cannot see any of the atom and not even using a microscope. Whatever microscope you may use, even if you use an electron microscope, so a very powerful microscope, then also you will not be able to observe an atom. Okay. So that is why the definition of the atom, how the atom is, it is all decided only by its studies. It is all guessed by the studies of the atom. Okay. We could not tell about the structure of the atom just by this, looking at it. Okay. So the discovery of this structure of the atom, it starts with the invention of the cathode rays. Okay, or cathode ray experiment, which was carried out by J.J. Thomson and his students. So cathode ray experiment or cathode ray tube. This experiment, cathode ray tube experiment, this was done by J.J. Thomson. And he was the one who discovered the electrons. Okay. So for this discovery of the electrons, he took out an evacuated glass jar, and in this evacuated glass jar he put two electrodes. So in the evacuated glass jar, eventually two electrodes were put. So there were two electrodes which were put, and the electrodes were connected with a battery. So this one is a positive electrode, negative electrode. You have this positive and the negative electrode, right? Now what happened when the voltage was increased? The here we took a gas at low pressure. There was a gas at low pressure only evacuated. That means all the gases were escaped out of it, and only a small amount of gas was kept inside this. Okay. So very small, a gas at low pressure was kept here. So what happened when we increased the voltage? He observed some sparking occurring between the plates, and these sparks they used to travel from the positive plate towards the negative plate. Since whenever sparking occurred, it meant that there are some charges. The sparking was observed by the charges. Okay. So that means there are some electrically charged objects, and he was able to guess out the electrically charged objects, that yes, these are the electrically charged objects, and these objects they carry a negative charge. So he found out that the objects carry a negative charge and they have a very small charge to mass ratio. He also calculated charge to mass ratio. E by m ratio is also called a charge to mass ratio of these particles. By finding out their kinetic energies, he was able to find out their charge to mass ratio. What would be their charge to mass ratio of these ejected particles which are between them? Okay. So first of all, the nature was identified, which was that they were negatively charged. The second thing, he was able to find out the charge to mass ratio of these particles. Okay. So that means these negative charges, they are coming from the atom. The negative charges, they are coming from the electrode. Obviously, some particles are coming. So that means the atom must be, atom is having these negative charges in it. With the atom which appears to be neutral, when all substances are made up of matter, and if you touch any of the, if you feel, so all the atom or all the matter particles, they are neutral. So atom is overall neutral. That means atom here, he found out that atom contains negative charges. Negative charges are located inside the atom and they have a very small charge to mass ratio. Their charge to mass ratio is very small. Okay. Got this?
Wait, so can you just explain gas of law, whatever is written?
A gas at low pressure. Low pressure. Okay. So that the gas does not ionize itself. This was so that the gas does not ionize itself. That is why the gas was taken at low pressure. Okay. Wait 1 minute, just 1 minute. Okay, let's continue now. So, what particles did J.J. Thomson discover? The particles which J.J. Thomson discovered, these particles, they were called, he called these particles as electrons. These particles were called as electrons. And the beam of electrons which was traveling from the positive plate towards the negative plate, that beam of electrons, it was called as cathode rays. Okay. So the beam of electrons, they were called cathode rays. Right? So these beam of electrons, they were called cathode rays. And he named these particles as electrons. Why they were called as cathode rays? Can anyone tell why these particles were called cathode rays? See, the positive electrode, it was called the cathode. Since these particles, Chavan, keep your mic off. Okay. So these particles, they were called as electrons. And the beam of electrons which was traveling from here, that beam of electrons or the sparks that was called, it was called as cathode rays. So here the electrons were discovered by J.J. Thomson. Now another thing started with that if atom overall is neutral. Okay. So if atom overall is neutral, then negative charges are coming out of it. Hence, the atom must also contain the positive charges. It also includes the positive charges, and hence the concept of the positive charges, it was now given by a similar experiment was performed. Okay. A similar experiment was performed by E. Goldstein. So canal rays. See, canal rays, they were discovered by E. Goldstein. Just wait here. Okay. So it was E. Goldstein who discovered about electrons, who discovered about canal rays. So it was easy for him to find out that there are certain particles which are positively charged. As from the atom only, J.J. Thomson was able to extract negatively charged particles. Okay. And those negatively charged particles were electrons. He named them as electrons. So a similar experiment, which was just similar to the J.J. Thomson's one, it was performed by E. Goldstein. So he also took a similar apparatus. A similar thing was done by him also. And he also took out two electrodes then, a positive electrode and a negative electrode. Again connected them with a battery. So see what happened over here. He also performed a similar experiment, but he made a small change in the experiment which J.J. Thomson was doing. So what change did he bring about? He created it at the cathode. He took out certain here. He took out certain holes. He created holes here, okay? And the holes which he created here perforated sheets. So these perforated sheets were taken over. Now, when he took the perforated sheets, So he found out that there are certain particles which are moving from the positive electrodes to the negative one, and these positively charged particles, they were called as protons. So he found out that these particles, they are moving towards the canal, and hence they are the canal rays. He found out their nature, that these substances, they are positively charged. Canal rays are positively charged, and he also find out their charge to mass ratio. But the charge to mass ratio of these particles, it was greater than the charge to mass. It was less than the charge to mass ratio of the electrons. Okay, so which proved that these particles or the protons, he called them as the protons which were positively charged. So here protons were discovered, and the protons which were discovered, they are positively charged. They carried positive charges. Okay. So he found out that the protons, mass of the protons, mass of protons was about 1,000 times. They were about 1,000 times heavier than electrons. So protons, they were 1,000 times heavier than the electron, and this was found out by E. Goldstein, who found out canal rays, or who started with the canal rays. So with these experiments, these two elementary particles, electrons and protons, were discovered. Okay. So who discovered electrons? Siddharth? Siddharth, who
Sir,
discovered electrons?
J.J. Thomson.
J.J. Thomson. And who discovered protons?
E. Goldstein.
E. Goldstein discovered protons. And who discovered neutrons?
Sir, J. Chadwick.
It was James Chadwick. So James Chadwick discovered about neutrons, and he found out that there are certain elementary particles which are uncharged. They are neutral, they are not charged, but they have their mass equal to that of the mass of protons. So these neutrons, they have mass equal to the mass of proton. So this was the conclusion which were drawn. So all these three particles were discovered. But before this, before the neutrons were discovered, came the J.J. Thomson again, and he put forward his J.J. Thomson put forward his here J.J. Thomson puts his theory of or structure of atom, which is called as the plum pudding model of atom. So J.J. Thomson, he gave plum pudding model of atom. So what was the plum pudding model of the atom? He assumed, see, up to now, whatever studies were made, so on the basis of those studies, it was confirmed that the atom is okay. See, so it was a plum pudding model, and according to the plum pudding model, since all the particles, they are arising from the atom only. Electrons are also arising from the atom. The protons are also arising from the atom. So therefore, from the plum pudding model, it was concluded that electrons and protons, both the charged particles, they are coming from the atom. So how will the atom look like? So this model of the atom, it was given by J.J. Thomson. The plum pudding model was given by J.J. Thomson. Okay. So the plum pudding model, what does it state? It states that atom is a sphere of positive charges. Atom is a sphere of positive charges. So atom is a sphere of positive charges in which negative charges are embedded. Negative charges are embedded. So it looks something like a Christmas pudding. It looks like a Christmas pudding, which is overall creamy, and in that you have the small elementary particles which are embedded. In our, you can assume your atom to be something looking like a. You can assume your atom to be something looking like a watermelon. So in this case, you can assume, suppose this is your watermelon. So in this case, you can assume that this is your completely positive charge. Okay. And within these positive charges, some elementary particles or some electrons, they are embedded inside. The electrons, they are embedded inside it like this, just like a pudding. Okay. So this was J.J. Thomson model, which was called as the plum pudding. Now, after the experiment of, after this plum pudding model, there were experiment uh, conduct just to prove this, that yes, this model is correct, to verify that yes, whether this model of the atom is correct or not. Okay. And it was suggested by E. Rutherford. So here E. Rutherford suggested out Rutherford, he was a student of J.J. Thomson. So he suggested how to perform alpha particle scattering experiment. So it was E. Rutherford who suggested for carrying out this experiment. He was a student of J.J. Thomson. And over there at the same time, there were two other students also who were Gigerson and Giger and Mardeson. These were the two other people. Okay. So they carried out this experiment in the year 1911, which was the alpha particle scattering experiment. So before we move on to the alpha particle scattering experiment, let us understand what are alpha particles. So can anyone tell what are alpha particles? Pranaya, what are alpha particles?
Sir, alpha particles are basically like helium, the particles of helium or something, which are like two helium particles actually, who are whose charge is negative, sir. Is it negative or positive?
Helium particles.
Like two helium ions.
Helium ions.
Yes, sir.
Helium ions. Helium ions are called as alpha particles. Okay. Or you can say helium nucleus is called as the alpha particle. So an alpha particle, it has a charge equal to, it has a charge of plus 2e, and it has a mass equivalent to 4 AMU. So mass of the alpha particle was 4 AMU and it has a charge of plus 2e. Now what was the thought process behind this? The experiment was planned to carry out the scattering of the alpha particle, that is the gold foil. That for this experiment, a thin gold foil was taken. A very thin gold foil was taken over here to carry out the experiment. And there were, you can say, detectors everywhere. So a detector was kept, which was made up of zinc sulfide. So this was a zinc sulfide which was kept like this. And from here, a source of alpha particle was kept over. So here a source of alpha particle was kept, from which alpha particles moved out. Source of alpha particle was taken as bismuth. So here a source of alpha particle was taken. And from here the alpha particles were made to bombard, or they were made to fall on this gold foil. So see, if we consider the structure as given by J.J. Thomson, if we believe that atom is what we see as J.J. Thomson told us, if that is the structure of the atom, then what would happen? Then in that case, these alpha particles, they should not be able to cross these. Okay, and hence they shall be able, or most of the alpha particle should return back. Okay. If this was true, if we thought that whatever J.J. Thomson had said about the atom, that it is a pudding, it is a sphere of positive charges in which negative charges are embedded. So if it was like that, so it would form a wall. Okay, it would behave like a wall and it will prevent the alpha particles from crossing it. But the results were entirely different. Whatever results were observed, the results were totally different from it. He observed that most of the alpha particles passed straight, only a few of the alpha particles deviated by small angles. Okay, so this was a very important conclusion, that most of the alpha particles are passing straight, undeviated. There is no deviation. Few of them, they are deviating by only small angles. Okay, and about 1 in 10,000 returns back with an angle of 180 degree. So only about, say, suppose some alpha particle is going like this, so it returns back with an angle of 180 degree or more. So here also the alpha particles are bouncing back with an angle of 180 degree. So here theta, or the angle, is equal to 180 degree. Only for 1 in 8,000 or 10,000. This was the number of the alpha particles which return back. So it means that whatever J.J. Thomson thought about the atom, that atom is a sphere of positive charge, that is certainly not correct. Atom is not a sphere of positive charge. Had the atom been a sphere of positive charge, so in that case, none of the alpha particles would have crossed it. Okay, so in that case, the alpha particles would not have crossed it, and they would have just, all the alpha particles, they would have just went over here and returned back. But since most of the alpha particles crossed it, so it gave an idea that inside the atom, most of the space is empty. So that is why the alpha particles are passing through it. Okay. Alpha particles, they are small particles. So why they are passing through the gold foil is the reason that most of the space inside the atom is empty. Atom is not what J.J. Thomson thought. Atom is something in, so to explain this, he considered the atom to be like this. So now he considers the atom to be like this. Okay, see. So how he thought the atom would look like. So according to him, the atoms are spheres, but they are all empty. Atoms do not have completely occupied. They have large spaces in them. So an atom, for the, he assumed that the gold foil is something like this. If this was the J.J. Thomson model, so this would have been a perfect solid and the alpha particles would not have been able to cross it. So he thought that this is the atom, but inside the atom, there is just a center of the positive charge. And all the other space inside the atom is empty. So you find a lot of empty space within the atom. Now, so therefore, if any alpha particle is passing like this, so that alpha particle will pass undeviated. Okay. If any alpha particle is passing close to the nucleus, so this alpha particle will suffer a deviation. This alpha particle will suffer a deviation like this. Here also he will be the alpha particles will suffer a deviation. Okay. So according to Rutherford, what Rutherford pointed out from here, that the atom has a different structure. It's not the structure which J.J. Thomson has proposed. Okay. He assumed that all the charges in the atom, they are concentrated in a very small volume inside the atom, which we call as the nucleus. So that is why he named this as the nucleus, and hence the name nuclear model of the atom. It was because of this that we got nuclear model of atom.
So why only alpha particles were taken for this experiment?
Okay. See, the reason for choosing the alpha particles was that they had a mass of 4 AMU. Okay. Why alpha particles we choose? That the alpha particles, they have a mass of 4 AMU. Over here we observe. They have a mass of 4 AMU and they have a positive charge. Okay. So the particle, if suppose we choose light particles, so the light particles, they will be deviated. Okay. But if alpha particles have a heavy mass, so that's not a too light. They are not too light. They have a little bit of mass. So therefore, they have a sufficient amount of kinetic energy. Okay. And if the so if they are not too heavy, so that they are going to go and take away the nucleus of the gold. Since the gold atom itself is heavy, the gold atom has an atomic mass of 79, atomic number of 79. So it has a mass of around 180 AMU. So therefore, alpha particles, they are quite light to it. And hence, if they collide with it, they will return back. So this was what was thought. And they were also positively charged particles. And he assumed that the atom is sphere of positive charges. So therefore, we require some positive charge only to come here and bombard with this atom. Okay. If he had to, taken some negative charges or electrons, so obviously the atom would absorb that also.
Oh, okay, sir. Thank you.
So we will be continue the discussion of alpha particles in the next class.
Okay,
Okay.
sir.
Bye everyone.
Bye, sir.
Good night.
Bye, sir.